Hello friends, today I'm here to discuss the solution to this problem which we discussed in class. Here is a differential equation which we have been given and the system of and the potential given by this plot where in the region 1 from x varying from 0 to 3 the v of x is 2, from a region varying from x equals 3 to 5 v of x is 5, and in the region where x is greater than 5 we have our v of x set to 0. Our task is to find out the final solution, that is f of x, by solving this differential equation. So before we start, let us understand what principles we need to keep in mind while solving this problem. So at the terminal edges, which is these regions, at x equals 3 and at x equals 5, we have to satisfy something called as the boundary conditions, as we have to do also at this terminal at x equals 0. We have already been given the boundary conditions here, that is f prime of 0 is 1 and f of 0 is 0. We'll see how we'll apply that. And also at these two terminals at x equals 3 and 5, we have to take care that our final function f of x is continuous and differentiable at each of these boundaries. So as and when we reach that stage, we'll discuss what exact solutions or boundary conditions we need to apply so that we can get essential constants out and get the complete solution of how f of x must be in order to satisfy this differential equation. So before we begin, we have the differential equation which we need to start up with. Let's write that down again. So we have minus d to f of x on dx2 plus v of x f of x equals e f of x. Now we have already been given the value of e, which is 4.5, as you can see here by this red dotted line. So in region 1, we have been given v of x to be 2. So we simply substitute both of these back into the differential equation and see what we get. So we have minus d2 f of x upon dx2 plus 2f of x equals 4.5 f of x, which gives me minus d2 f of x upon dx2 equals 2.5 f of x. So this is the differential equation we get in for region 1. The standard solutions for this, as we discussed in class, let me just rewrite this a bit as phi upon 2 f of x, just for simplicity. So our differential equation finally looks like this. Now the standard solution to this differential equation, we know since there is a negative sign here, we can write our f of x in the region 1 to be of something of the fashion like a cos of square root of 5 upon 2x plus b sine of square root 5 upon 2 of x, where a and b are both unknown constants. Similarly, so let me call this equation 1. In the region 2, we have f of x, v of x given to us as 5. So we substitute that back in this master equation. Let me call this let me call the master equation equation star. So r minus d2 f of x upon dx2 plus the v of x, which is 5 f of x equals 4.5 f of x. So we have minus d2 f of x upon dx2 equals minus 0.5 f of x, which can be rewritten as d2 f of x upon dx2 equals 1/2 f of x. The standard solution for this kind of an equation can be written as f of f in the region 2 of x equals c e to the power x upon square root of 2 plus d e to the power minus x upon square root of 2, where c and d are again unknown constants. And in the region 3, we have been given v of x equals 0. So when we substitute that in the master equation, we get minus d2x on dx2 plus 0 times f of x equals 4.5 f of x. Therefore, we end up getting d2 f of x upon dx2 equals 9 upon 2 negative sign f of x. Now, standard solutions again for this kind of an equation in region 3 can be written down as e times cos of square root of 9 upon 2 x plus f times sine of square root of 9 upon 2x. Now we can simplify this and rewrite that as cos of square root of 9 is 3, so upon 3 upon square root of 2 of x plus f sine 3 upon square root of 2 of x. Now that we have the standard solutions for all of these three regions, the only thing remaining is applying boundary conditions and getting values for each of these constants a, b, c, d, and e and f. That should give us the complete solution for this f of x in this region. And now, to begin with, in the region 1, we have been given these boundary conditions. So our f of x looked like a cos, if I'm not wrong, it's square root of 5 by 2 x plus b sine square root of 5 by 2 x in the region 1. And it looked like c e to the power x upon square root of 2 plus d e to the power minus x upon square root of 2 in region 2. And it looked like e cos of 3 upon square root of 2x plus f sine of 3 upon square root of 2x in region 3. Now, to begin with, we have our boundary conditions. F prime of 0 equals 1 and f of 0 equals 0. Now we'll apply both of these boundary conditions to our first differential equation. So in that case, our f prime in region 1 of x equals square root of 5 by 2 times a sine of square root of 5 upon 2 x minus b cos of square root of 5 upon 2 x. So f of 0 equals 0 should be applied to the region 1, and thus a times cos of anything like 0 is always 1 plus b times sine of 0 is always 0, and that is equals to 0. Therefore, we have a equals 0. and in the second region, in the first derivative of our f of x at 0 is 1. Therefore, substituting 0 in this equation, we get square root of 5 upon 2 times. Now we already know that a is 0, so we'll neglect that term. We have b times cos of 0, which is 1. So I'll just write that as 1 equals 1. Therefore, we have the value of b equals 2 upon square root of 2 upon 5. So we have the values of a and b readily here from our first boundary conditions. The next boundary conditions you need to apply are at, so let me use a different color, boundary conditions at x equals 3. Now the boundary conditions here would be f of f in region 1 of 3 should be equal to f in region 3, and f prime in region 1 at 3 should be equal to f prime of in region 2 at 3. So our f prime of x in region 1 is already written down here, but our f prime of x in region 2, since our f of x in region 2 looked like c e to the power x upon square root of 2 and d e to the power minus x upon root 2, we can write that as 1 upon square root of 2 c e to the power x upon square root of 2 minus d e to the power minus x upon square root of 2. And let's rewrite our f1 prime of x again. That looked something like this. So I'll just copy that. Oops. All right. So first we apply this boundary condition here, and so the left hand side is f at in region 1 at 3. That would give me the value of b we already know is square root of 2 upon 5. So I substitute that here. Square root of 2 upon 5 times the sine of square root of 5 upon 2 at 3 should be equal to c e to the power 3 upon square root of 2 plus d e to the power minus 3 upon square root of 2. So this is our second equation in the solution, and applying the second equation here, we write down f prime in region 1 at 3, which is the left hand side, 5 upon 2. A we know is already 0. B we know is square root of 2 upon 5 cos square root of 5 upon 2x. So this is the f prime of f prime in region 1 at 3. Just write down 3 here. And that should be equal to f prime in region 2 at 3. So that is 1 upon square root of 2 c e to the power 3 upon square root of 2 minus d e to the power minus 3 upon square root of 2. So here I am just cancelling out the square root of 2 on both sides here. So I get rid of the square root of 2 here and the square root of 2 here. So I just remain with square root of 5. Let me call this equation 3. Now, if I add both of these equations, we can see that the d term completely cancels out on the right hand side. So we just have 2c times e to the power 3 upon square root of 2 and the sum of both of these constant values in the left hand side. And here again, I see that since this is multiplied by square root of phi in the denominator, I can completely get rid of the square root of phi here as well. So I just have minus square root of 2 times cos of this constant plus square root of 2 upon 5 times sine of this constant. Therefore, we write, let me just write the right hand side on the left hand side right now. So I see that 2c times e to the power 3 upon square root of 2 equals square root of 2 upon 5 sine square root of 5 upon 2 times 3 minus square root of 2 cos of square root of 5 upon 2 times 3. And therefore, my c is 1 upon square root of 10 sine of 3 square root of 5 upon 2 minus 1 upon square root of 2 cos 3 5 upon 2. This entire thing times e to the power minus 3 over root 2. So this is my value of the constant c. Similarly, I can find out the value of d by subtracting both of these equations 2 and 3. Let's do that and write down the final values. So on the left hand side, I have 2 times d e to the power minus 3 upon square root of 2 equals square root of 2 upon 5 times sine of 3 square root of 5 upon 2 plus square root of 2 times cos of 3 square root of 5 upon 2. Therefore, d equals 1 upon square root of 10 sine 3 square root of 5 upon 2 plus 1 upon square root of 2 cos of 3, this entire bracket multiplied by e to the power 3 upon square root of 2. So we also now have the constant value for our fourth constant d. Now the next step and the last step of this solution is to apply boundary conditions again at this terminal boundary as we discussed at x equals 5. So at x equals 5, we again have the very similar boundary conditions. F in region 2 at x equals 5 must equate to f in region 3 at x equals 5. And f prime at x in region 2 at x equals 5 must be equal to f prime in region 3 at x equals 5. Now, our f prime in region 3 and of x is from this equation can be written down as 3 upon square root of 2 times e sine of 3 upon square root of 2x minus 3 upon square root of 2 f cos of 3 upon square root of 2x. And let's rewrite f prime of 2, f prime in region 2 of x, that we remember is 1 upon square root of 2 c e to the power I think it's x upon square root of 2 minus d e to the power minus x upon square root of 2. Now we substitute these values at x equals 5. But before that, let's write down our first equation. So we now consider C and D as known values. So we'll just get the solutions of E and F in terms of C and D, and then substitute C and D later to get the entire constant value of E and F. So we have C equal e to the power 5 upon square root of 2 plus d e to the power minus 5 upon square root of 2 equals e cos of 3 upon square root of 2x. Sorry, at 5, right? So this should be multiplied by 5 plus f sine of 3 upon square root of 2 times 5. So this should be, remember, I think this should be called equation 4. And let's rewrite that into the more simplified version, which is e cos of 15 upon square root of 2. Let me just recheck if we are substituting the correct values. Yes, so this can be rewritten down plus f sine 15 upon square root of 2. Let me call this equation 4. Now we equate the first derivatives of f in region 2 and 3 at x equals 5. That should be 1 upon square root of 2 c e to the power minus 5 upon square root of 2 minus d e to the power minus 5 upon square root of 2 should be equal to 3 upon square root of 2 times e sine of 15 upon square root of 2 minus e cos of 15 upon square root of 2. I'm sorry, this should be f. And let's just call this equation 5. So we need to use both of these equations, 4 and 5, to get final values of E and F in terms of C and D. As a result, we'll have to eliminate E from one of these equations using the other equation. So since we have sine here and cos here, let's just multiply both equation 4 by cos of this constant value and equation 5 by the sine of this constant value. But before that, all right, so let's just do that. So multiply equation 4 by cos of 15 upon square root of 2 and add that to equation 5 multiplied by sine of 15 upon square root of 2. So equation 4, and the left hand side of equation 4, before that, let's just simplify the equation 5. So here I will get rid of the square root of 2 since they appear on both the sides, and divide both left and right hand side by 1 upon 3. So I'll divide this by 1 upon 3 and this as well. So now we have both the coefficients of both E and F on the right hand side as 1. Now let's call this revised equation as equation 5 and this equation as it is as equation 4. So on left hand side we have C e to the power 5 upon square root of 2 plus D e to the power minus 5 upon square root of 2 times cos of 15 upon square root of 2 plus the left hand side here gives me 1/3 C e to the power 5 upon square root of 2 minus D e to the power minus 5 upon square root of 2 times sine of 15 upon square root of 2 equals, again on left and right hand side I will have okay, so I will have to subtract these equations. Now I realize. So I will have this minus this, and this should be e cos of 15 upon square root of 2 sorry, it should be plus. It should be plus. So e cos of 15 upon square root of 2 squared plus e times sine of 15 upon square root of 2 squared plus f cos of 15 upon square root of 2 sine 15 upon square root of 2 minus f sine of 15 upon square root of 2 times cos of 15 upon square root of 2. So we can see that the f terms completely cancel out and we are only left with e on the right hand side. Therefore we have e, let me just write that on the left hand side now, and e equals this entire thing. Let's just rewrite that down. So we have c times e to the power 5 upon square root of 2 cos of 15 upon square root of 2 plus 1/3 e to the power 5 upon square root of 2 times sine of 15 upon square root of 2 plus d e to the power minus 5 upon square root of 2 cos of 15 upon square root of 2 minus 1/3 minus 5 upon square root of 2 sine of 15 upon square root of 2. Great. So we now have our final solution for E. We just need to substitute the values of C and D which we obtained earlier in this equation, and similarly we can find out the value of F. In that case we would have to do very similar operation, but to obtain F we will have to multiply F4 with multiply equation 4 with sine of this constant and equation 5 with the cos of this constant, and subtract both of these, because if you observe carefully both of these equations, you will have to subtract sine multiplied by equation 4, subtract cos multiplied by equation 5 from sine multiplied to equation 4, so that you get f on the right hand side, because the identity which you obtain here is cos square plus sine square, which is nothing but 1. So we write that directly as e. And similarly, we do a similar operation to uh, obtain f on the left hand side. So we can write f equals, doing this operation, we would get, um, we will have to multiply c e to the power 5 upon square root of 2 plus d e to the power minus 5 upon square root of 2 by sine of 15 upon square root of 2, and subtract that from c times e to the power I forgot this factor of 1 by third. Okay, perfect. So we now have our solutions obtained for um, E and F as well, which are like the constant values for in the third region. Therefore, our solution remains the same now that we have applied boundary conditions. Our F final small f of x. We now know the values of a equals 0, b equals square root of 2 upon 5, the entire square root of 2 upon 5. We know the values of c and d from the equations we solved out, and values of e and f. So we now know the complete solution for f of x. So this was the solution. This is the similar idea we would be using to solve boundary value problems in quantum mechanics for a well box in a well, particle in a well box, and finite potential values with energies greater than 0 and less than 0. So um, uh, this is the similar idea we would be using of boundary conditions at the terminals and maintaining the continuity and the differentiability of the equations. So hope if you have any more questions, just approach me with any mistakes you might find, and thank you so much.